Okay, welcome to class today. We are going to discuss addition and subtraction of fractions today. So, I want to start by defining what a fraction is. A fraction is simply a part of a whole. So, to have a whole object, like a whole orange, I'm going to draw an orange here. Let's say a whole orange here. The whole orange is an orange. Oh, so big. Make the ink small. The weight of the ink should be smaller. So if you have an orange like this and you divide it into two, that's 1 out of 2. That's 1 out of 2. 1 over 2. So that's a fraction. That's a fraction, part of a whole. So in this addition of fractions, we're going to divide this topic into two for today. First is going to be addition of fractions that have like denominators. I want you to remember that in a fraction, the number up is called the numerator. The number up here, like in this 7 over 12, 7 is called the numerator. Okay, it's called the numerator. N-U-M-E, numerator. And this is R-A-T-O-R. This is the numerator. The number up is called the numerator, while the number down is 12. It's 12 here. In all the fractions, the numbers down are called the denominators, which is here. Denominator. The denominators. The denominators. Okay, the number down, the denominator. Denominator. This is nator. Denominator. Can you see that now? Yeah, so in the fraction, these are things that we have, the numerator and the denominator. So we're adding fractions that have the same denominator, that's like means the same. After that, we'll add fractions that have unlike denominator, that's they have different denominators. So let me clean that denominator part up, okay, so that we can solve the fraction better. Right. So I want us to solve the first question. There's a rule that we follow. There is a rule we follow for addition of fractions. For addition and subtraction generally. And this is the rule. Anytime you have two fractions that have the same denominators and you want to add or subtract them, this is what you do. Since the denominators are the same, you pick one of them. Pick one of the denominators, write it down. Right, then you add the numbers that are up. 7 plus 3. Remember, let me say it again. Look down on the denominators and check if they are the same. And if they are the same, just pick one of them. In this example 1, I have 12 as the denominator of the first fraction. and I have 12 as the denominator of the second fraction. So they are the same. The denominators are the same. The numbers down are the same. So I pick one of them, which is 112. I write it down. Then I add the numbers up. So if I add the numbers up, 7 plus 3, that's 10 all over 12. So that's what you get. But we can still break this fraction to the lowest term. We can still break this fraction to its lowest term by dividing the fraction by a common factor. By a common factor. Let's say, for instance, like 2 can be the factor. 10 divided by 2 is 5. 5. And 12 divided by 2 is 6. So let me write this 5 very well. This is 5, okay? So that's 5 over 6. So that's our answer for that first question there. 5 over 6. So we'll be able to add that fraction. So now we are going to go to the next example. We are going to go to the next example. This is 5 over 6 as our final answer. 5 over 6. So we're going to go to the next example now. Next example, which is 11 over 15 minus 4 over 15. So what can you see here about their denominators? Anytime you have a question like this on addition or subtraction of fractions, the first thing that you need to always check is their denominators. Check, are they the same or different? If they are the same, follow the rule by picking one of the denominators and adding or subtracting the numerators, which are the numbers up. But if the denominators are not the same, you will need to make them the same. That's the work that you have to do. So it's pretty easy. So let's solve this one here. This denominators here is 15, here is 15, so they are the same. So I'll just pick one of the denominators. This is 15. I'll write it here. And the numerators, I'll just subtract them because there's a subtraction sign. Remember, this rule works only for addition and subtraction, not multiplication and division, okay? No multiplication and division in this rule. This rule works just for addition and subtraction of fraction. So 11 minus 4, that's what? That's 9. No. That's 7. 7 over 15. And this fraction here, there's no factor that this numbers can divide. I mean, there's no factor that 7 can divide and 15 can divide at the same time without a remainder. So our final answer is 7 over 15. What about the next example here? Just pick this 9 and then add the numbers up. 5 plus 2. And that's going to be 7 over 9. That one, so cannot be broken down into the lowest term. This is the lowest term already. 7. This is 7. I'm going to write like this. 7 over 9. Can you see that? Okay, let's see this next one here. This example 4. The rule stands. What Are the denominators the same? That's what we need to check for. And I can see there's a 16 here and there's a 16 here, so I pick 116. And then the numbers of the sign is subtraction now. So that's going to be 14 minus 5 up. And guess what the answer is going to be? 14 minus 5, that's 9 now. Okay, 9 over 16. Unfortunately, there's no other number that can that both 9 and 16 can divide without a remainder. So that example is gone down too. That's pretty easy, right? Yeah, so the next thing now we need to solve is solving fractions, adding and subtracting fractions that do not have the same denominators. And we call it unlike denominators. What we mean by that is that we want to solve fractions whose the numbers down for the fractions are not the same. Look at this fraction. This is 2 over 3 plus 1 over 6. The denominator of this first fraction is 3, while the denominator of the second fraction is 6. So as you look at these denominators, are they the same? No, they are not. 6 is not same as 3. So when their denominators are not the same, what do? The best way to solve this problem is to make the denominators the same. And how do we make these denominators the same? This is how we do it. You pick this fraction here. Pick this fraction here. This whole fraction. Multiply it by the denominator of the second fraction. Can you see the arrows there? The arrows will help you out. Pick this first fraction, multiply by the denominator of this second fraction, and then you pick the second fraction, you multiply by the denominator of this first fraction. Can you see how this work is done? So let's do it. This is 2 times 6. This is 2 times 6 because it's 2 of that first fraction. 2 times 6. Sorry, write that. 2 times 6 all over. Clean that up. Clean that. 2 times 6. 2 times 6. All over 3 times the same 6. Remember, the whole fraction we're multiplying by 6. Plus, now I'm picking the second fraction on my right, and I'll multiply by the denominator of the first fraction on the left. So that's 1 times 3 all over, what's the number down? 6 times the same denominator. 6 times 3. So what is our answer going to be now? 2 times 6 is 12 over 3 times 6, 18 plus 1 times 3, that's 3 over 6 times 3, 18. Can you see what has happened now? Look at the denominators of these two fractions that I've got here. Are they the same or different? Oh, they are the same now. The first fraction is 12 over 18. Plus the second fraction is 3 over 18. we have made the denominators to be the same. So now that the denominators are the same, what do we do next? What do we do? Pick one of them, one of the denominators. Pick one of the denominators. I'm on the next line now. I'm on a next line now. One of the denominators, which is 18. 18. Then add the numbers up. That's 12 plus 3. And 12 plus 3 is going to give us what? That's going to give us 15 over 18. Can you see that? 15 over 18. That's our final answer, but we can still break this fraction down to its lowest term. So what number do you think 15 and 18 can divide without a remainder? What number is that common factor of 15 and 18? The greatest common factor. And that number is 3. I can see that's 3. So 15 divided by 3 is 5. 18 divided by 3 is 6. So our final answer now is 5 over 6. Can you see that now? 5 over 6 is our final answer. 5 over 6. So that's how this is done. So our final answer is 5 over 6 for that unlike fraction is equal to 5 over 6. Okay, so that's how it is done. That's how it is done. There are many other examples there. Maybe let's solve one last one before we go. Let's solve one last one before we go. 5 over 6 is the answer for that one. Let's solve one last one before we go. Yes, look at this one here. Look at this one here. 3 over 5 plus 2 over 10. The denominators are not the same. So what do we do? Can you guess? You can pause the video and try to guess how we can do it. Follow these steps you have solved to get your own done too. Okay, well, let's do it together. So what will I do? I'm just going to be using the arrows to help me. So I draw my circle here. This whole fraction on my left times this number, the denominator of the fraction on my right. And I pick the fraction on my right, the whole fraction on my right, multiply it by the denominator of the fraction on my left. So that the denominators can now become the same. Yeah, I know that there's another short way that you can do it is check if this denominators, one of them, can actually divide the second one. So you make it the same. You put it down and try to maybe divide by this denominator and multiply. Yeah, there are many other ways, but for this video, we are using this method. We pick this fraction on the left, multiply it by the denominator of the fraction on my right, and then pick the fraction on my right, multiply it by the denominator of the fraction on my left. So let's do it. So that's 5 and 3 times, what's the denominator on the left? 10. So 3 times 10. 3 times 10. All over, pick this fraction down, this number down. 5 times 10. 5 times 10 plus, now we're picking this fraction on the right and multiplying it by the denominator of the fraction on my left, which is 5. So 2 times 5, 2 times 5. Let me do that. The space is not enough, so I'm trying to draw a line to show that this question is different. I think let me clean this other part away so that it won't be a confusion. There will be no confusion there. So 3 times 10 over 5 times 10 plus 2 times 5, 2 times 5, all over the number down times 5 again, because 5 is the denominator that we are multiplying the whole fraction on the right by. So 10 times 5. So this is going to give us 3 times 10, 30. 30 over 50 plus 2 times 5, 10. 10 over 50. 10 over 50. You see 10 over 50 there? 10 over 50. So when we add them, are the denominators the same now? Yes. So what do? We'll pick one of them. So I'm picking one of the 50s here. I'll draw my line and pick 50 here. What do I do to the numbers up? I add them. 30 plus 10. And that's going to give us what? 30 plus 10, 40 over 50. 40 over 50. So you can break this down by cancelling, dividing both sides by 10. 10 into 40 is 4, and 10 into 50 is 5. So the final answer is 4 over 5. 4 over 5. So that's where we'll stop for today. We are going to continue from here in our next class. Thanks for listening. Please subscribe to my YouTube channel for more videos. So bye for now.